Welcome to Anto PRISCI Educational Academy. In this session I am going to explain you a simple problem in random variable. So given, let us see the example. Given a random variable y, given a random variable y with a characteristic function characteristic function phi of omega is equal to expectational of e power I omega y, expectational of e power I omega y, which is equal to cos omega y plus I sin omega y, cos omega y plus I sin omega y, and x of t is equal to cos of lambda t plus y, cos of lambda t plus y. Show that x of t is wide sense. X of t is wide sense if phi of 1 which is equal to 0 and phi of 2 is equal to 0. Phi of 1 is equal to 0, phi of 2 is equal to 0. Okay, so let us see how to solve this problem. Answer is, first you have to write phi of omega, given one is expectational of e power I omega y, which is equal to cos omega y plus I sin omega y. So phi of 1 is equal to e power expectational of e power I y, omega will be 1, cos y plus I sin y, expectational of cos y plus I sin y. Okay, so which is equal to 0, expectation of cos y I sin y, which is equal to 0 because phi 1 is equal to 0. So expectation of cos y, okay, which is equal to 0, expectation of sin y, which is equal to 0 from phi of 1. Next to phi of 2, which is equal to 0. So therefore expectation of e power I2y, which is equal to 0. So cos, expectation of cos 2y plus I sin 2y, which is equal to 0. So therefore expectation of cos 2y is equal to 0, I sin 2y is equal to 0. So expectation of cos 2y is equal to 0 and expectation of sin 2y is equal to 0. Okay, so these 2y is equal to 0. So next, you know the conditions for wide sense stationary process. What is the condition? So wide sense stationary process, there are two conditions. First one is expectation of x of t, which is equal to constant. Second condition is the autocorrelation Rxx of t1 comma t2 is a function of time difference t1 minus t2, time difference t1 minus t2. Okay, so let us see how to satisfy these two conditions. First one, e of x of t. So expectation of x of t, which is equal to expectation of, what is x of t? That is given in the problem, cos lambda t plus y, cos of lambda t plus y. What is cos of a plus b? Cos a cos b minus sin a sin b. So e of cos a means lambda t, cos y minus sin lambda t sin y, sin lambda t sin y, which is equal to cos lambda t into e of cos y minus sin lambda t into expectational of sin y. What is the expectation of sin y? That is 0. What is the expectation of cos y? That is 0. Already we have already noted e of cos y, e of sin y is equal to 0. Therefore e of x of t is equal to 0. So constant. So first condition we have proved, e of x of t is equal to constant. First condition satisfied. Second condition is Rxx of t1 comma t2, which is equal to expectational of x of t1 x of t2. Okay, so x of t1 x of t2. What is x of t? That is also given in the problem. X of t is equal to, so which is equal to expectational of x of t1 cos lambda t1 plus y into cos lambda t2 plus y. Okay, so which is equal to expectational of cos lambda t1 cos y minus sin lambda t1 sin y into cos lambda t2 cos y minus sin lambda t2 sin y. So this is a sin lambda t2 sin y. So therefore if you are multiplying, you will get, which is equal to expectation of cos of lambda t1 cos of lambda t2 cos square y minus cos of lambda t1 sin lambda t2 cos y sin y minus cos lambda t2 sin lambda t1 sin y cos y plus sin lambda t1 sin lambda t2 sin square y. So this is okay. So now cos square y sin square y. So everything we can write. This is cos y sin y. This can be written as, so which is equal to expectational of cos lambda t1 cos lambda t1 cos lambda t2 expectational of cos square y. So we are going to take the expectation on both sides. So if I are taking expectation on both sides, every cos square y, we are going to take expectation on cos square y minus cos lambda t1 sin lambda t2 expectation of, what is sin a cos a? So sin 2a by 2. So expectation of sin 2y divided by 2, sin 2y divided by 2. Okay, so next you have to take minus cos lambda t2 sin lambda t1 expectation of sin 2y divided by 2, because sin y cos y can be written as sin 2y divided by 2 plus sin lambda t1 sin lambda t2. Okay, so expectation of sin square y. So everything we have written, which is equal to, what is the sin 2y? 1 by 2 into sin 2y, that will be 0. Sin 2y, expectation of sin 2y already we have got, that is 0. So you will get only these two terms. So cos lambda t1 cos lambda t2 expectation of 1 minus cos This will be 1 plus cos 2y divided by 2. 1 plus cos 2y divided by 2. Next, plus sin lambda t1 sin lambda t2 1 minus cos 2y divided by 2. 1 minus expectation law 1 minus cos 2y divided by 2. Expectation law 1 minus cos 2y divided by 2. Okay. So next, which is equal to cos 1 by 2 cos lambda t1 cos lambda t2 into expectation of 1 will be 1 plus 1 by 2 into cos lambda t1 cos lambda t2 expectation of cos 2y plus 1 by 2 sin lambda t1 sin lambda t2 into expectation of 1 will be 1 minus sin lambda t1 sin lambda t2 expectation of cos 2y. So what is the expectation of cos 2y? 0. What is the expectation of cos 2y? That is 0. Already we know. So we have got. So that's why, which is equal to 1 by 2 is common. Remaining is cos lambda t1 cos lambda t2 plus sin lambda t1 sin lambda t2. So you have to write only this one, which is equal to 1 by 2 cos A cos B plus sin A sin B can be written as cos A minus B. So cos lambda t1 minus t2. So this is a autocorrelation function. So second condition is also satisfied. It is a time difference. That's why the given function is, hence the given function is, hence it is wide sense stationary process.